All right, in this video, we are going to be looking at double replacement reactions. In double replacement reactions, we have the first element that's going to be switching with the first element, or the first thing within this reactant that's going to switch with the other one. With these, I'm going to encourage you to identify the charges of every single piece of the reactants before you begin. This will help you come up with the correct answers on the product side more easily. So we have a positive 2 for magnesium, negative 2 for oxygen, and then we have the positive 1 and negative 1 for sodium chloride. Just very quickly, here's the magnesium plus 2, here's the oxygen minus 2, sodium plus 1, chlorine minus 1. When we switch these two elements, it's always going to be the first ones that switch. We are going to first start by identifying the answers without any of those subscripts that are not part of a polyatomic ion. Now we need to use the charges to figure out the correct chemical formulas. And we already have them on the reactant side. Those charges are not going to change from the reactant side to the product side. So if we carry those charges over, magnesium is still positive 2, chlorine is still negative 1, sodium positive 1, and oxygen minus 2. Now we've been doing this work with the other one, so it should be pretty simple at this point. Magnesium chloride is MgCl2, and sodium oxide is Na2O. And for the final time, chlorine here starts with only 1 on the reactant side. It ends with 2 on the product side. Remember that this is something that we'll be dealing with in a little while. We don't need to worry about why there is an extra chlorine on the product side. All we need to worry about is that we show the charges and we use those charges to come up with the correct chemical formulas. Let's get rid of our work. And go on to the next one. Aluminum is going to be positive 3. Bromine is minus 1. Potassium is plus 1. Phosphate is minus 3. And phosphate is this entire thing right there. Remember that clue, if we have 3 different elements in a chemical compound, and we see oxygen there, that is our clue to identify it as a polyatomic ion. Here's phosphate, negative 3. All right, so we can use this information to come up with the correct chemical formulas for the products. Here is aluminum phosphate and potassium bromide. Notice that I did not carry over any of these subscripts. These subscripts are identified because of the charge, right? We needed to have 3 of those bromines in order to get the overall charge equal to 0. This one right here is a polyatomic ion. Polyatomic ions have to stay as a package, just as they are written on this polyatomic ion sheet. Charges stay the same, positive 3, minus 3, positive 1, and minus 1. All of those charges are the same, positive 3, minus 3, minus 3. Potassium is positive 1, and bromine is negative 1, and negative 1. Notice that the charge that I use here is what it is for a single element, not the overall charge of all of them put together, just of the single element. Now we can use that to come up with the correct chemical formula. This one is the easiest that we have on this page because there's nothing to do. All we have are those charges that cancel, positive 3 and negative 3, positive 1 and negative 1. Let's get rid of the work, clean it up. Don't need that as part of our final answer. All right, a little bit more quickly. We have a negative, let's do this one here. Positive 1 and negative 1 from the potassium and chlorine. Now we go over to this guy right here, the lead nitrate. if we go to the periodic table and identify lead, it is not one of the elements available to us to use the periodic table to figure out the charge. These are +1, these are +2. So +1, +2, this is +3. This row right here, where lead is, we don't have a rule for. So instead, we have to use what is bonded to. Nitrate, right here, we can look up on the polyatomic ion sheet. Nitrate is -1. So if we identify that as -1, that means that lead has to be +2. That's because we have two of these things that are -1, gets us a total of -2. If the overall charge has to be 0, which it does, we need a +2 from that lead. Now we have all the information that we need in order to make these products. That lead is going to switch places with that potassium, end up with PBI, and then we end up with KNO3. Let's do the charges. Lead is still +2. Right here, it didn't change. Iodine is still -1. Potassium is +1 and nitrate is -1. So the only thing we need to do for this one is to add a subscript right behind that iodine. That allows us to get that -2 from the iodine, overall charge equal to 0. Let's erase these guys. The charges, don't need those charges as part of our work. All right. Okay, next one. A little bit more quickly now. Chlorine is -1, which means that iron has to be +3. Let's look at that real quick. Here's chlorine, -1. Here's iron. We had to use context clues to figure that out. Since there are 3 of these chlorines, that means that iron has to be a +3. +2 for the calcium, -1 for the hydroxide. I'll show you the hydroxide. Right there, -1. We end up with an answer then of iron and hydroxide and calcium and chlorine. Charges stay the same. +3 for iron, -1 for that hydroxide, +2 for the calcium, -1 for the chlorine, and now we can add subscripts. 3 there. Notice the parentheses because I need to have 3 of that thing, that package. And then over here, 2 for that chlorine. Let's get rid of our work. And now we can do the very last one. This one is, as they are progressing more difficult, the most difficult, because we have a polyatomic ion that does not have oxygen. This is just one that you kind of have to memorize. NH4 is the only polyatomic ion that we will use that has a positive charge, and it's +1. So that makes ammonium +1. Chlorine is -1. Over here, we have to use that same information that we did before. Nitrate is -1, and iron is +2 in this case. Notice that up in here, in this reaction above, iron was +3. And in this reaction, it's +2. That charge for these guys in the middle can change. So that's why we can't use a rule to figure out what their charge is. We have to use what it is bonded to. Nitrate is -1. We used it up here, right there, -1. And now we can use that information to come up with the correct answer. Iron and chloride plus ammonium NH4 and nitrate. Charges are the same on the product side, plus 2 for iron, minus 1 for chlorine, plus 1 for ammonium, minus 1 for the nitrate. So the only thing that we need to do here, add a subscript for that. Want to make sure you see here, no parentheses was used here because we have one of each of them. One of each of them means no parentheses. Parentheses are used here because there's 2 of it. All right. Here are 5 to try on your own. Go ahead and put your answers in the correct place, and I'll grade those when they are done.